Let us study chemistry together with CBSE Chemistry Tips and Tricks.
Hi everyone, this is the fourth part of our daily NEET practice series. Moving to our first question. See, this question is from 2022 NEET question paper. The compound which shows metamerism is. For doing this question, first of all, you must know what is metamerism. See, same functional group but different alkyl group on either side of a divalent atom. You know, right? Either show metamerism, secondary and tertiary amines show metamerism, ketone show metamerism, correct? If you check the option, you cannot see any nitrogen. So question is not about secondary or tertiary amine. It can be about either because oxygen is there, or it can be about ketone, right? Okay, now we can check. From the molecular formula, how can we understand whether a compound is ketone or ether? For that purpose, you must know the general formula. Okay, so for ketone, what is the general formula? It is CnH2nO. And for ether, it is CnH2n plus 2O. Clear? One more important hint is there. Ketones show metamerism only if the number of carbon is equal or greater than 5. Okay, keep that point in your mind. Now regarding ether, it shows metamerism only if the number of carbon is equal or greater than 4. Now we can check. Option number 1, C3H8O, whether it is ketone or aldehyde. How can we check that? Substituting this formula, see, put 3 here, okay, C3, then 2 into 3 plus 2, that is 8O. Got it right? C, instead of N you put 3. Now H, 2 into 3 is what? 6. 6 plus 2 is what? 8O. So it is an ether, but the number of carbon is lesser than 4. So it cannot show metamerism. Directly understand like that, okay? You have to use the hint, otherwise it take a lot of time. Now next one is what? C3H6O. It is ketone. So you can check here. C3, right? Now 2 into 3 is what? 6O. It satisfies the general formula of ketone. Okay, so it's a ketone. It can show metamerism, but what is the problem? The number of carbon is just 3, lesser than 5. Okay, so it cannot show what? Metamerism. Moving to the fourth option. Before saying third one, I am going to fourth option. Okay, see, fourth option is what? You know, what is the general formula? CnH2n plus 2 is the general formula of alkane. So this is an alkane, okay, which will never show metamerism. C5H12 is what? Pentane, right? Pentane, that you already know. Simple thing. And it cannot show metamerism. Now we can check the third option. Regarding third option, C4H10O, it satisfies the general formula of ketone or aldehyde. Sorry, ketone or ether. Check it. Of course, it satisfies the general formula of ether. Check it. Here, what is that? C4, right? Now, 2 into 4, what is that? 8 plus 2, 10. Okay, right? So, C4H10O satisfies the general formula of ether. So, it's a ether. Now, it contains 4 carbon. Clear, right? So, definitely it will show what? Metamerism. Now, we can check which are the metamers of C4H10O. We can check that. You understand it is ether, right? Okay. So now see CH3, O, CH2, CH2, CH3. What is the name of this? Methoxypropane. Now CH3, CH2, O, CH2, CH3. What is this? Ethoxyethane. So ethoxyethane and methoxypropane are metamers. Okay, right? Same functional group but different alkyl groups on either side of the oxygen. You can see methyl group and propyl group, ethyl group and ethyl group. Hope you understand. Okay, right? Is it clear? Second question is from 2022 NEET paper. Tritium, a radioactive isotope of hydrogen, emit which of the following particle? It is a straight question, okay? You must know the beta decay of tritium. I will write the beta decay of tritium C13. This is tritium it convert to helium 3. Okay, helium 3. This is helium 3 by releasing what? By releasing beta. Beta particle means what? Electron and antineutrino. Antineutrino. This is beta decay of tritium. Okay, this you must by heart. So what is our answer? Beta. And regarding alpha, you know, alpha are emitted by heavy nuclei like uranium. Gamma rays are high energy photons which emit out after an alpha or beta decay. Right. Neutrons normally does not emit out. They just convert to proton. Right. So what is our answer? Beta, which means electron. Got it right? One last thing. See, this is beta particle. Okay. Instead of this, you can write what? Beta minus. Same. Okay. To represent electron. Our third question is from 2022 NEET paper. The mixture which shows positive deviation from Raoult's law is. For doing this question, you must know this hint. If molecules are similar, then mostly they form ideal solution. Similar in the sense, similar in their structure and similarity in their polarity. Okay, for understanding, we can take the first and third example. If you check first example, you can see chloroethane and bromoethane. See, both are haloalkanes. They have huge similarity in their structure and both are non-polar. So, of course, they will form what? Ideal solution. Now, if you check third option, again you can see benzene and toluene. There also both are non-polar and they have huge similarity in their structure. So, again they are ideal solution. Now we have two options left, option second and option 4. When we make a solution, definitely see there will be a new bond established between solute and solvent, right? Correct. If that new bond between solute and solvent, there is a physical interaction between the molecules, right? So for example, between ethanol molecule, there is a physical interaction like hydrogen bond. Between acetone molecules, see there is some physical interactions. Now what we are doing, we are making a solution by using ethanol and acetone. So what will happen? The existing bond will break and a new bond will establish between ethanol and acetone. Right? A new bond is established between solute and solvent. If that new bond is stronger, then the deviation is negative. Okay. Now if you check option number 2, see, the already existing bond before mixing is hydrogen bond. Very strong bond, right? So on mixing, what happened? Acetone definitely disturbed that hydrogen bond. So that new bond will be weaker than the existing bond. The new bond will be weaker than the existing bond. So it won't be negative deviation. If the new bond are weaker, then it is what? Then it is positive deviation. So that is our answer. Clear? If the new bond are weaker, see, you have to understand, before mixing there is very strong hydrogen bond exists between ethanol molecule. Now we mix acetone and ethanol, right? What will happen? Definitely the hydrogen bond between ethanol molecule get disturbed by the new acetone molecule. Clear, right? So the new bond established will be definitely weaker than the already existing hydrogen bond. See, last one is acetone and chloroform is a classical example for negative deviation. See, when you mix acetone and chloroform, very strong hydrogen bond exists between acetone and chloroform, right? So new bond are stronger. If new bond are stronger, then it is negative deviation. So this is a classic example for negative deviation. Okay, negative deviation. So what is our answer? Ethanol plus acetone. Got it right? Question number 4 from 2022 NEET paper. Noble gases are named because of their inertness towards reactivity. Identify an incorrect statement about them. Okay, we can check one by one. First statement is noble gases have very high melting and boiling point. Is it correct? No, right? Absolutely wrong. Why? See, we know noble gases are monoatomic, right? Monoatomic. Second, see, they are non-polar nature. Okay, non-polar nature. So there is no possibility of dipole-dipole interaction at all. Okay, the only force which held the noble gases together are what? Weak London dispersion force. Okay. Weak London dispersion force. If the intermolecular force is weak, then boiling point and melting point will be definitely what? Low. If the intermolecular force is weak, then we know, right, the melting point and boiling point will be definitely low. Okay, for example, helium. Helium is an example for noble gas and its boiling point is minus 269 degrees Celsius. Got it? That much less. Check point number 2. Noble gases have weak dispersion forces. Same thing, right? Same thing. We discussed it already. Before moving to the third option, you must know what is the meaning of positive electron gain enthalpy or what it represents. It represents the atom is not ready to accept electron. Okay, that point you keep in mind. Now, assume if electron gain enthalpy is negative, what is the meaning? Then it means atom is ready to accept electron. Okay, so assume you have A, B, C, D. A, B, C, D, just for understanding. Minus 1, just for understanding, okay? Minus 2, minus 1, 2, 3, just for understanding. These values are actually not correct. Now, see, I am asking which have maximum tendency to accept electron. Of course, A, because their electron gain enthalpy is maximum negative. And which one have least tendency to accept electron? Of course, it is D, because it has maximum, means maximum positive electron gain enthalpy. Got it, right? So noble gas have large positive value of electron gain enthalpy. Is it correct or false? So for that purpose, first of all, we have to understand noble gas. Is noble gas have any tendency to accept electron? No. Why? Because noble gas already have completely filled valence shell. Then why they accept electron? No, right? They do not want to gain electron. So their electron gain enthalpy is positive and of course large, which means unfavorable to accept electron. Clear, right? For understanding fourth option, you must know non-polar solute dissolve in non-polar solvent and polar solute dissolve in polar solvent. Here, solute, that is noble gas, is non-polar, correct? And water is of course polar. So what about the solubility? Definitely less, right? Noble gas will be less soluble in water. Noble gas are sparingly soluble in water. That statement is correct. Statement is correct. We need incorrect statement, right? So which one is incorrect statement? First one. All other statements are correct. Clear? Moving to our fifth question. See, question is from 2020 NEET paper. Reaction between acetone and methyl magnesium chloride followed by hydrolysis will give. For doing this question, you must know this hint. Methanol. Methanol, adding with Grignard reagent and hydrolysis, you will get primary alcohol. Other aldehyde, other than methanol, adding Grignard reagent, hydrolysis, you will get secondary alcohol. And ketone, here we are dealing with ketone, right? Adding Grignard reagent and hydrolysis, you are going to get tertiary alcohol. You are going to get a tertiary alcohol with how many carbon? For understanding that, acetone means what? CH3, COCH3. So 3 carbon. Now methyl magnesium chloride, what is that? CH3 is methyl magnesium chloride. So in methyl magnesium chloride you have 1 carbon. Acetone you have 3 carbon. Total how many carbon? 4 carbon. So you are going to get a tertiary alcohol which contain 4 carbons. Clear? So straight answer, right? Straight answer. Tertiary butyl alcohol. Clear? Tertiary butyl alcohol, what is the structure? See, this is the structure, right? You know, it can't see, no need of doing the things and all. Okay, directly you will understand. Ketone, Grignard reagent and hydrolysis, you are getting tertiary alcohol. And how many carbon it contain? Total 4. 3 plus 1, 4. Okay, so what is the only option? It is tert butyl alcohol. Clear, right? And this is that structure. So option 4 is our right answer. Our fourth session is now complete. Thank you all for watching this video.